Right, so let's begin with the solution to quadratic equations using factoring. We will use factoring by grouping. So let me remind you what a quadratic function is. A function. So let's define what a quadratic function is. Quadratic function. So a function of the form f of x equal to ax square plus bx plus c is called a quadratic function. In x, provided, what is the key condition on it? A is not equal to 0. Because as soon as a becomes 0, the function becomes linear. Just a note on the side, this is important, all quadratic functions or all quadratic equations have solutions in the complex plane. So if a quadratic equation does not have a real solution, it will have a solution in the complex plane, and it can always be determined. What I want to say is that all quadratic equation solutions can be determined. Okay, so since we are emphasizing only on how to solve a quadratic equation using factorization, let's see what determines whether a quadratic equation is factorable or not. So let's take an example, and I'll first give you an example of a quadratic equation that can be solved by factorization, and then I'll give an example of a quadratic equation which cannot be solved by factorization. So what determines, how do we determine that, is by discrimination, by discriminant. So discriminant is this quantity, b square minus 4ac. And note, if discriminant is a perfect square, then a quadratic equation can be solved by factorization. Otherwise, one could employ quadratic formula or complete the square method. So either quadratic formula could be applied or complete the square method to find the solutions. Okay. So these two formulas could be employed. So it can only be solved by factorization if the discriminant is a perfect square. If the discriminant is not a perfect square, then we have to either employ quadratic formula or completing the square method. Okay, so let's take an example. An example would be, let's take the example. Example would be 6x squared plus 7x minus 20. Now notice this is a quadratic expression. If I take this function equal to f of x and I set f of x equal to 0, What does that graphically mean? It means that I am setting y equal to 0, which means that the solution of the quadratic equation is the value or set of values of x for which y is 0. So it is basically a graph where the graph would intersect with the y-axis. Alright, so let's try to see how do we solve it. Or first, let's apply the discriminant and see whether it can be solved by factorization or not. So let's first do that. We observe that A is 6, B is 7, C is -20. Important thing to notice, we are not just looking at the numerical values, but the signs are also important. So we saw that A is +6, B is +7, C is -20. So let's find that quantity, B squared minus 4AC, which is 7 squared minus 4 times 6 times -20. This is 49. This is positive, negative times a negative. 4 times 6 is 24, 24 times 20 is 480. This gives us 529. And it is a perfect square. Why? This is a square of 23. So when I square 23, I'll get 529. All right. So we know that this particular equation, hence 6x squared plus 7x minus 20 is equal to 0 can be solved by factorization. So that's the first thing we needed to know, whether it can be solved by factorization or not. Any questions about it? So you're given an equation. If they tell you, hey, can it be solved by factorization? The first thing to do is find the discriminant. If it is a perfect square, yes, you can solve it by factorization. If it is not a perfect square, then you cannot solve it by factorization. All right. So let's try to now solve this. And this is a paradigm. Always follow this paradigm. And if I could give you the steps, this would be the steps. These would be the steps. First step, multiply A and C. Whatever answer you get, let's say we call it P. Let's say A times C is equal to P. Then we find factors of P such that the sum of the factors is equal to B. And then the third step would be replace them, and then fourth step would be factor by grouping. If we follow this routine, all factorable quadratic functions can be factored. So first step, multiply A with C. Whatever number you get, you find factors. Those factors must add up to, sum up to the middle term, which is B. Okay. What those factors are, replace them. And then once you replace them, just do factor by grouping. Okay. So let's look at that. And here it goes. Remember, we started with this particular function. This is the equation when we set f of x equal to 0. Let's factor it out. 6x squared plus 7x minus 20 is equal to 0. Multiply 6 with a -20, which will give you -120. Now the factors of -120 are 1 and -120. So when 1 is positive, the negative sign must come from 120, or 1 could be negative and 120 could be positive. If you add them, if you sum them up, your sum can only be -119 or +119. Well, that's not the number here. You're looking for 7. So let's just try one more. 2 and we could have 60. This has to be positive, negative, negative, positive. And then again, that's not going to work either, because you could have negative 58. Let's continue on with the 3. And what are you going to get? You're going to get 40 with a negative and a positive. No, they don't add up to that. What about 4? 4 would be 30. Negative and a positive. We could also have 5. And in the case of 5, what are we going to get? 4 and 44. Let's check, is that going to work? 5 times 4 is 20. 20 and, no, this is not right. It should be 24. Let's continue on with the 6. You'll have 20. Are we getting close? I don't think so, because this will give us 12. 7 cannot be 7 is not a factor, so we would have to go to 8. Yes, 8 does divide, and in the case of 8, I think it should work, because we will have negative 15 and positive 8. Now notice, positive 8 minus 15 gives us negative 7. Are we looking for negative 7? No, we are looking for positive 7. So the other factor should work, where 8 is negative and 15 is positive. So you replace negative 8 and positive 15 here. So it should be negative 8x plus 15x. Don't forget the x, minus 20. Form 2 groups. There is this group and this group. What can we factor out from both of these? I see an x that could be factored out. Here we have x times x, here we have 1x. So we could at most factor 1x, but also 6 and 8 have 2 in common, so we could factor that out. So we are left with 3x minus 4. Observe, if I multiply it, I'll get back both of these. So 2x times 3x will give me 6x squared. 2x times negative 4 gives me negative 8x. Now the key thing is signs should be also kept in mind, that when you multiply, the signs should return back to the same signs that we have before. And what can we factor out from these two? 5, they don't have x in common, so 5 would be factored out. Now factorization is, again, the important thing is you should get the same quantity within the parentheses. There shouldn't even be a difference of signs. So if I factor out a 5, I'll get a 3x, and I'm left with a 4. Okay. Now both of these, when you see them, there is this particular term and this particular term. Both of these terms have 3x minus 4 in common. So we could factor that out. And what are we left with? We are left with 2x from here and plus 5 from here. Okay, and here is the key step. We are doing this on the set of real numbers. And real numbers have this property that if you're multiplying two things and the answer is 0, then at least one of them has to be 0, which means that either 3x minus 4 is 0 or 2x plus 5 is equal to 0. This would give me x is equal to 4 over 3, and this will give me x is equal to negative 5 over 2. And these are the two solutions. Now observe, if I graph this particular parabola, what would its graph look like? What information is this giving me? It is giving me a vital information that if I graph this parabola, now I know it is facing up. It is facing up because your a is positive. It tells me that x is intersecting with the y-axis at negative 5 over 2. So if it is negative 1, negative 2, negative 3, so there is this point where the parabola is cutting, and at 4 over 3, this is 1, this is 2, so somewhat over here. So if I graph this parabola, it's going to be like this, facing up, and these are the 2 points where it cuts the x-axis. Did I say y-axis earlier? No, it's x-axis. Where does it cut the x-axis? That is where this is x-axis where y is 0. That's what I wanted to say. x-axis where y is 0. Okay, so when we see it over here on the on our projector, that is the presentation before you guys on Desmos, we will see that this parabola intersects at the same points that we determined. At x is equal to negative 2.5, y is 0, and x is 1.33, which is 4 over 3, y is 0. So these are the points where that happens. Thank you. That's how we solve quadratic equation